Hello guys, today we will solve a medium problem that is mathematical number of type nodes after connecting trees. The version one is about a graph problem, and maybe there's a version two harder than this. Mm, okay, let's type into this problem. The statement give us the access to undirected tree with n and n nodes. Okay, okay. This just the add links. Node node U is target to node B if the number of edges from the path from U on the path from U to V is less than or equal to K. Okay, we have K here, and node that's always target to itself because its number of edge is 0. Return an array of n integers enters where answer I is the maximum possible number of nodes target to node I. But for tree, if you have a connect one node from the first tree to another node in the second tree, node that creates an independent. Okay, so like let's take the example one. The node 0 in the tree 1 can travels to 1, 2, 3, 4. Yes, within k equal to 2. Then we initially we have 1, 2, 3, 5 nodes. Already 5 nodes. And if we have an edge like net node 0 from the first tree to node 0 or the second tree like this, and it's gonna be uh, from 0 to 0 node of tree 2 is cost 1, and then we can travel to node 3, node 2, node 3, and node 1 of the tree. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, yeah, 9 here. So there, that's a sample. For example, node 4, we can travel to node 3, 2, and 0. That's the 4, and travel to line node 4. 4 here, we gonna get more 4, more 4, so we got 8. Yeah, 8 here. So what is the assumption here? Observations. Yeah, as 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 we all know that if we want to maximum the numbers of what target from a node like this, we must add an edge from that itself to tree 2. Why? Because as we know that the the more the more step the small step we have in the tree, the more node we can reach. For example, if you know from 2 to 0, it's gonna k equal to 2, so it's gonna reduce to 1 if you travel from tree 1 to tree 2. And if you didn't use this connect, you may connect the 0 to 1, so you must take one unit to travel from 2 to 0, and then you only have k equal to 1, and then travel from 0 to 0, and it's gonna k equal to 0 to no more step. That's so that I say the higher step remaining, the higher the more nodes we can reach. So always connect from the itself, but the node we do the query here to the node from tree 2. But what the connect we need to step here from that node to what node in the tree 3. Simply just connect to the node that can go reach as many nodes as possible. That's it, node 0. You can reach to with k equal to we know it. When we travel from tree 1 to tree 2, k become k minus 1. In this first example is k equal to 2, so we only have k equal to 1 if you travel to node 3, node 2. So node 0 can reach this, and this is 3, while this node 7 only reach one node, that is 2. The same case at 4, you can travel to this, and it is the like 4 node. Now say this for nodes 2, and you can connect to this or this, whatever, it's the same nodes. So the final solution here is to find in a tree. We need to find the node with maximum target node, maximum target within k minus 1 step. Okay, because as I say, we need one step to travel from tree 1 to tree 2. And in tree 1, for each node, we need to find how many nodes, how many target node E node U can reach. So why we call it like F U. So the answers U is like F U because the math in tree 2 is now. Okay, as you can see, the limit, the constraints here is about 1000, so we can do for loop. Yeah, for loop only. So maybe you can have the OM solution, but it's about the maybe tomorrow problem, the version 2 of this. Okay, now to catch up. Okay, let's do on the tree 1. We need to find the FU. Okay, FU. We can use the basic route traverse algorithm like DFF defined, like starting from a node so travels until you can't travel anymore. Okay, so I will use DFF for simplicity purpose. DFF from the U and the step here. Okay, and we also not from YouTube. We need to create the iteration magic. Step we don't travel to parent. Different piece, so we can do the DFF with you. Now the new parent is U and step minus 1. Step minus 1 is count here like 1 because we count the node U. Okay, like if step is less than 0, so we turn like 0. This maybe do something like that. Okay, return count. Let's create a graph. 0 to side. I think we should pass the better here. Decide how many yes as one side plus 1. Yeah. Just as 1 and 0. 0 h1 1 h1 0, so push here, push back because it's undirected, so we must push back to edge UV and BU. I think we need to do on the second tree first to find the mass. Okay, let's check. Map tree 2 0 first. The node from side n here side h1 side plus 1 side plus 1 2 2 get n plus 1 mass in 3 2 right in 3 2 with here back node I with line minus 1 is no parent and step minus 1 that in case minus 1 and the graph we use here this check it out is let's print out to make sure our code work properly. Yes, it works perfectly. Yeah, got it. You h20. What do you do? Too many mistakes, but not the logic mistake. Okay, you can see this four is four like 1, 2, 3, 4. This is my current. With case 2 is like 1. Case okay. That's right. That's right. So now we set the I know we need to we use the addresses matrix here to reduce the like reduce the memory space. Okay, we don't need to travel on tree 2 anymore. That's one. Do something like you by just one. So just just respect E respect E. So for answers here 0 to n answers I equal to like the bad I minus minus 1 of the step k and adjacencies metric plus mass in 3 2. That the answer. Submit. Companies. What's company? Oh my god. Fail. Let me check it out. Take. Oh my god. Oh my god. Okay. Back to this. I can't believe that's the k equal to 0 in the test case. I missed reading the limit here. Okay, 100%. That's a good sign. Okay, have a nice day. Goodbye.